Dear students, in my first lecture, you have studied the concept of tube of force, tube of induction, normal electric induction, total normal electric induction. In today's lecture, we are going to study the Gauss Law or Gauss Theorem and its proof. As we know that the Coulomb's law gives the relationship between electric field and electric charge. In the similar manner or in the same analogy, the Gauss law also gives the relationship between electric field and electric charge. But here condition is that there is a symmetric charge distribution. And the statement of this Gauss theorem is so in case of Gauss theorem, we must have electric charge, and this electric charge must be enclosed by some surface, or charge must be enclosed by the surface, and the surface may be regular shape or is of irregular shape. And the statement of this Gauss theorem or Gauss law is the total normal electric induction over a closed surface. That means electric charges are closed by a surface of any shape. That means suppose this is the closed surface placed in a medium of permittivity, epsilon is equal to epsilon k, and if the number of charges are situated inside it, some charges may be positive and some charges may be negative, or all the charges may be positive or all the charges may be negative. So main condition is that total normal electric induction over a closed surface, we must need a closed surface, and that closed surface encloses the number of electric charges. Then this law states that the total normal electric induction over a closed surface of any shape and any size with any number of electric charges enclosed in any position inside the surface, then T and EI over the closed surface is equal to the algebraic sum of electric charges enclosed by that surface. That means T and EI is equal to summation Qi from I is equal to 1 to n and is equal to total charge. That means algebraic sum of charges enclosed by the surface. And we have to prove this T and EI is equal to summation Qi. And for this purpose, we consider a surface of any shape. Suppose this is the surface which is placed in a medium of permittivity, epsilon is equal to epsilon 0 k, and in this medium, inside this closed surface, for the simplicity, consider a charge plus Q is situated at point O inside the closed surface. So a closed surface which encloses a charge plus q. Then consider a point P on this closed surface and around which again consider a small area ds. And the electric intensity at this point is directed radially outwards. And from figure we observe that this electric intensity is not perpendicular to the area ds. Hence, we have to draw normal to this area ds, and this normal makes an angle theta with the direction of electric intensity. And now the component of electric intensity E cos theta is perpendicular to this area ds. And by the definition of total normal electric induction, charge plus q is situated inside the closed surface, and we consider a small area ds of this closed surface of any shape, then TNEI over area ds is given by formula epsilon E cos theta into ds. Suppose this is equation number 1. So TNEI over ds is epsilon E cos theta into ds. Again, we know that the magnitude of electric intensity E is given by the formula E is equal to 1 upon 4 pi epsilon into Q divided by R square. Suppose this is equation number 2. Now substitute equation number 2 in equation number 1. We get again TNEI over area ds is equal to epsilon into value of E is 1 upon 4 pi epsilon into Q divided by R square into cos theta into ds. And now suppose this is equation number 3. And in this equation, this epsilon and epsilon gets cancels. So TNEI over area ds is equal to Q divided by 4 pi, in bracket we write ds cos theta divided by R square. And this is equation number 4. And in this equation number 4, the term which is in the bracket ds cos theta divided by R square is called solid angle subtended at point Q by area ds. So solid angle subtended by ds at O, and this is denoted by d omega. So in figure, this is the solid angle subtended by area ds at the charge plus q, and which is d omega. And therefore, equation number 4 becomes, we write again TNEI over area ds is equal to q divided by 4 pi into d omega. And this is equation number 5. So this is the value of total normal electric induction over this small area ds. Now we want to find the value of this total normal electric induction over a entire closed surface, and therefore we have to take the integration of equation 5. So by taking the integration of equation number 5, we get TNEI over closed surface, which is equal to integration over closed surface equation 5, which is q divided by 4 pi into d omega, and which is equal to q upon 4 pi outside the closed integral d omega, which is equal to q divided by 4 pi into 4 pi. And in this case, the value of closed integral d omega, which is equal to 4 pi steradian, and this is called as total solid angle subtended by entire surface at O. So the value 4 pi is nothing but the total solid angle due to entire surface area which is subtended at point O. So in this equation, this 4 pi gets cancels with this 4 pi, and we get the final equation for total normal electric induction over a closed surface, and this TNEI over closed surface becomes simply Q, because we have considered for simplicity only a single charge plus Q, which is enclosed by the surface of any shape and any size. If number of charges are situated inside this closed surface, that means charges plus Q1 plus Q2 minus Q3 plus Q4 minus Q5 and so on. If large number of charges are situated inside this closed surface at any position, then by the principle of superposition of charges, we have to sum all the charges, or we have to take the algebraic sum of all the charges enclosed inside the closed surface. And therefore, this total normal electric induction over closed surface for number of charges enclosed is given by formula TNEI due to number of charges enclosed by the surface is equal to summation Qi. I takes values from 1 to n, or which is equal to capital Q. So this is the proof of Gauss law or Gauss's theorem. That the statement of Gauss theorem is the total normal electric induction over a closed surface of any shape and any size with number of electric charges are enclosed inside it is equal to the algebraic sum of electric charges enclosed by that surface. So this is the proof of Gauss Law or Gauss Theorem by using the concept of tube of induction. So while taking the proof, we have used here the concept of tube of induction as we have already studied in my first video. So TNEI using the concept of tube of induction is given by TNEI over closed surface is equal to algebraic sum of electric charges enclosed by that surface. Now, as TNEI comes out to be summation Qi, I is equal to 1 to n, or TNEI over closed surface becomes algebraic sum of electric charges enclosed by the surface, that is capital Q. Now, if a charge enclosed by a surface is positive, if the charge enclosed by the surface is positive, then this TNEI over closed surface is considered to be positive. So in terms of TNEI, TNEI is considered to be positive if the charge enclosed by the surface is positive. Second case, if the charge enclosed by a surface is negative, then this TNEI is considered to be negative. Again, third case, suppose that a charge is situated outside the closed surface. This is our closed surface and charge is situated outside the closed surface. Then in this case, TNEI is equal to 0. So these are the three cases. If charge enclosed by the surface is positive, then TNEI is also considered to be positive. If charge enclosed by the surface is negative, then TNEI is considered to be negative. If charge is not inside the surface but it is outside the surface, then in that case TNEI is equal to 0, because in this case when charge is situated outside the closed surface, then the number of tubes of induction entering the surface must be low from the surface, and hence TNEI is equal to 0 if the charge is situated outside the surface. So this is the one of the statement of Gauss theorem. TNEI over closed surface of any shape and any size with any number of electric charges enclosed by that surface is equal to the algebraic sum of electric charges enclosed by the surface. Now we will discuss the alternative statement of Gauss theorem. And the alternative statement of Gauss theorem is the total electric flux through a closed surface is equal to 1 upon epsilon times the net charge enclosed by the surface, or which is equal to Q divided by epsilon 0 Q. Okay. So net charges enclosed by the surface divided by permittivity of the medium gives the total electric flux through the closed surface. And this alternative statement can be easily proved by considering a sphere having radius r, and that sphere will encloses a charge plus q. So this is the charge plus q, and this charge plus q is enclosed by the sphere, and the charge q is at the center. Now consider a point P on this surface and consider small area ds around the point P. Then the electric intensity at point P is directed radially outwards, and this electric intensity E is directed radially outwards at every point on this sphere. Now this alternative statement can be proved by considering the concept of electric flux. So by the concept of electric flux, the electric flux through area ds is given by the formula d phi over ds is equal to E into ds. And the value of E, that means electric field intensity, is 1 upon 4 pi epsilon 0 into Q divided by R square into area ds. So electric flux through small area ds by the concept of electric flux is equal to E into ds, because here small area ds and electric field intensity are perpendicular to each other, and therefore we find the total electric flux phi E over a closed surface, and this can be obtained by taking some summation of this equation number 1 or by integrating equation number 1 over a closed surface, and integration over a closed surface is equal to 1 upon 4 pi epsilon 0 Q divided by R square into ds. Again the constant terms, which is 1 upon 4 pi epsilon 0 into Q divided by R square into closed integral of ds, which is equal to 1 upon 4 pi epsilon 0 Q divided by R square, and the value of closed integral over ds for this sphere, which is 4 pi R square. And therefore this 4 pi gets cancels. Again this R square gets cancels with this R square, and therefore final result is the total electric flux through a closed surface is equal to Q divided by epsilon 0. That means the alternative statement of Gauss law, which is the total electric flux through a closed surface is equal to net charge enclosed by the surface divided by epsilon 0. So total electric flux over a closed surface is equal to summation Qi, I equal to 1 to n, and it is divided by epsilon 0. So if number of charges are situated inside this closed surface, that is sphere, then the total electric flux over a closed surface becomes summation qi, I equal to 1 to n divided by epsilon 0. Again, this total electric flux may be directed inwards, or it may be directed outwards, or it may be zero, and it depends upon the charge enclosed by the surface or charge is outside the surface, which is similar to the total normal electric induction conditions. Now suppose a charge enclosed by the surface is positive, that is plus q, then total electric flux through the surface is directed outwards. And in case of T and EI, we have considered that if the charge enclosed by the surface is positive, then this T and EI is also positive and is directed again outwards. Secondly, if the charge enclosed by the surface is negative, the total electric flux over the closed surface is directed inwards. That means electric flux is directed inwards. Here electric flux is directed outwards. And it is a similar case for T and EI. If charge enclosed by the surface is negative, then T and EI is negative considered and directed inwards. And final case, if the charge is situated outside the closed surface, then phi E is equal to 0. Similarly, T and EI is also equal to 0. So these are the different cases. If the charge is situated inside the surface is positive, then electric flux is directed outwards. T and EI is also directed outwards. If the surface encloses a charge which is negative, then total electric flux is directed inwards, and similarly total normal electric induction is also directed inwards. If charge is outside the closed surface, then both the terms total electric flux as well as total normal electric induction becomes 0. So from the two statements of Gauss theorem, we draw some conclusion. So first statement of Gauss theorem says that T and EI over closed surface is equal to summation qi, I equal to 1 to n, that is total charge enclosed. This is first statement or mathematical form of Gauss theorem by using the concept of tube of induction. And the alternative statement is the total electric flux through a closed surface is equal to total charge enclosed by the surface divided by epsilon 0, or simply epsilon. So from these two cases or these two statements, we can draw conclusion that both the total normal electric induction and the total electric flux through the closed surface depends on charge enclosed by the surface. So this T and EI as well as total electric flux depends upon the charge enclosed by the surface. Secondly, T and EI as well as total electric flux through the closed surface is independent of number 1, shape and size of closed surface. Again, it does not depend on the radius of the surface. Again, it does not depend upon the situation of charges enclosed by the surface. So T and EI as well as total electric flux only depends upon the charge enclosed by the surface. That does not depend upon the shape and size of the closed surface, or it does not depend upon the radius of the surface which encloses the charge, and it does not depend upon the situation of charges placed inside the closed surface. But here the total electric flux through a closed surface depends upon the factor dielectric constant of the medium, that is K here. So this is all about Gauss theorem and its two statements, one which is based on the concept of tube of induction, and another statement which is based on the concept of